Hello student, last day I explained the AC distribution single phase system which was radial system. Today I will solve a problem of AC distribution. Here AB is a distributor and last terminal, that is at B point, the voltage is 240 volt. That means the distant end voltage is 240 volt and current at the B point is 100 ampere at 0.8 power factor lag. Between A and B there is a midpoint M. Here the load is 100 ampere and its power factor is 0.6 lag. Here, according to abbreviation, I mean last time B, current at B, I am writing I1 and power factor point is written as cos phi 1. And here at end point, the current is I2, that is 100 ampere, and cos phi 2, that is 0.6 lagging. Now, the impedance of the distributor is given, that is ZAV vector is equals to 0.2 plus J 0.3, that is resistance is 0.2 and inductive reactance is 0.3. Now, as the M point is the middle point, so ZAM and ZMB section is equal. At first, we write ZAM .1 plus J 0.15, that is divided by 2. This also is equals to ZMB section equal. Now, let the M point is writing at a voltage at M is Vm and voltage that is feeding end I am writing as Va. Now I have to calculate what is the voltage across M and A. Given the voltage as the last terminal is 240 volt, current and power factor also given. Now first I write Vm is equals to Vb plus this current is I1 angle minus phi 1 minus sign because lagging, multiplied by Z MB section. So at first, for calculation this, we have to draw phasor diagram. Now, taking the last terminal voltage, that is VB, taking is the reference. Point 0.8, that means cos phi 1 is equals to 0.8. So by scientific calculator we can find phi is equals to cos inverse 0.8, angle will be 36.87 degree. So with respect to VB, I1 is lagging at an angle 36.86, which is abbreviation, we can write I1. Now, as the VB is the reference, so angle will be the 0 degree. So here you can write the voltage is 240 volt, angle is 0 degree. I1 given 100 ampere minus 36.87 multiplied by ZMB section 0.1 plus J 0.15. Now this calculation can be done by calculator, by scientific calculator. Shift angle 0 plus 100 shift angle minus 36.87 multiplied by within bracket 0.1 plus 0.15 shift. So if this result is shifted to polar system, by polar system this will be 270, 257.07 shift angle is 1.33 degree. Now the voltage across this point, calculate Vm equal to 257.07. Now this current is 100 ampere is 0.8, which is abbreviation 100 ampere is writing as 100 I2, and 0.6 writing is cos phi 2. Now current this portion is the vector sum of I1 as I2. equals to I1 plus I2. Okay, at first we'll complete this vector diagram. This is the drop I1 into 0.1 this portion and I1 into 0.15 this portion, and this portion is I1 into Z MB. Okay. Now I1 is 100 ampere. As angle is minus 36.87 plus I2. I2 100 ampere and angle. Here is a vital point. There is a vital point is, what is the angle here? What is I2? I2, the angle between phi 2. What is phi 2? Phi 2 is the angle between Vm and I2. So phi 2 is the cos phi 2 is equals to 0.6. So phi 2 is equals to 53.13. My calculator, as cos phi 2 is 0.6, so phi 2 is inverse cos of 53.13 degree. So now this angle phi 2 is the angle between Vm and I2. So with respect to Vm, I draw this I2. So this angle is phi 2. Now I2 is 100 ampere, and angle, actually the vector is always with respect to reference line. Here I2 drawing from Vm, but actually I2 will be with respect to VB. So this angle will be, this is the, we require this angle. From this to this is 53.13 and this angle is 1 So this we can write I2 is plus 100 ampere minus 53.13 plus 1.30. So I2 magnitude is 100 ampere but its angle will be with respect to reference lines. Given the point 6 with respect to Vn, so this is the minus sign, so angle will be some decreases. So according to by calculator, this will be 53.13 minus 1.33. No, 53.13 minus 1.33. So this is 51 point minus 51.8 degree. 53.13 minus 1.33. There is also plus sign. So from this to this angle is 53. From this to this angle is 51.4. Now we draw this. So according to calculator, 100 shift minus 36.87 plus 100 shift angle minus 51.8 shift 198 where 3 angle minus 44.335. So the resultant current, this sections of the AM section, current is 198.3, angle of 44.33. That here in vector diagram we can write this angle will be minus 44, this will be the 44 angle. 44.335. Now VA can be calculated by VM voltage plus voltage across this drop. Now you can write VA vector is equals to VM plus current is I and Z AMs ZAM sections. So this voltage is sorry, this voltage this will be VM plus voltage drop across AM sections. So VM voltage is 257.07 angle 1.33 plus 198, current is 198.3 angle minus 44.335 within bracket 0.1 plus J.15 257.07 shift angle 1.33 plus 198.3 shift angle minus 44.335 multiplied within bracket 0.1 plus 0.15 shift J bracket close shift in polar form equals to 292.278 angle is 2.62 degree. This is the voltage across the VM. Now I complete the full vector diagram from VM we draw parallel with I this portion. This is a perpendicular here. This is V. There is a drop. This portion is a drop of I into this resistance, and this portion I into inductive reactance, and total drop we can write total drop, that is we can write I into Z AM. M portion. Now this power factor is angle between VB and I1. This angle is phi1, and power factor angle at the M point is VM and I2. Now the power factor at the sending end, that is A, is the angle between VA and I. So the power factor of this angle is, if we write cos phi A, cos phi A means power factor of the sending end, which is angle between VA and I, that is, there is the VA and then I. So this angle we can write, that is phi A. So what is phi angle? This angle is power factor of this portion is angle between VA and phi. It can be calculated because this portion is 44. This portion, if we add, suppose this portion is alpha. So the power factor of the A is equals to cos of 44.335 plus this angle is 2.62. So with this is the reference line. So VA angle with respect to VB, which is 2.62 degree. If we add from this to this angle is 44.4 plus this angle, if we add 2.62. So if we add, and by the help of calculator, this also lagging, we can measure, not measure, we calculate the power factor at the sending end. I hope this is a very complicated problem. So if you solve 2 times, minimum 2 times, you can easily solve this type of problem. Thank you, all of you.